Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P1717, indicates an open circuit in the transmission range switch, specifically pertaining to the ATPRVS, Automatic Transmission Park Reverse Switch, circuit of the Honda Odyssey model years 2011 to 2017. The transmission range switch is an essential component located attached to the transmission assembly, and it plays a critical role in signaling the current gear position to the vehicle's engine control module, ECM. A malfunction in this circuit can lead to difficulties in gear selection and can interfere with the proper functioning of the transmission. This issue is purely electrical and is not attributed to mechanical faults in the transmission itself. When addressing this DTC, technicians often start by recording all freeze frame data, which provides insights into the vehicle's conditions at the time the code was generated. This information is crucial for effective troubleshooting and serves as a baseline for further diagnostics. DTC P1717 indicates an open circuit specifically in the ATPRVS circuit, which is a crucial part of the transmission range switch system. The transmission range switch is vital for relaying the gear position to the vehicle's engine control module. Located on the transmission, it ensures that the vehicle can properly detect the selected drive mode, such as reverse or park. Without accurate feedback from this switch, the vehicle may exhibit abnormal transmission behavior, including issues that affect start and stopping mechanisms. By recognizing its location and function, technicians can better focus their diagnostic efforts. Given that this issue is electrical and unrelated to mechanical issues, it narrows down the troubleshooting approach substantially. The potential causes for DTC P1717 are primarily related to electrical circuit failures and components connected to the transmission range switch. One common cause is an open circuit, which could result from damaged wiring or connectors affecting the continuity of the ATPRVS signal. A faulty transmission range switch may not send the correct signal due to internal malfunction. In addition, poor connector conditions, such as corrosion or poor contact, could disrupt the electrical flow necessary for proper signaling. Being aware of these factors can significantly speed up the troubleshooting process as they guide technicians toward the most likely offenders in the circuit. It's crucial to check not just the components, but also the wiring and connections in the vicinity of the switch. A vehicle exhibiting DTC P1717 may show several notable symptoms. Key among these is improper shifting of the transmission, particularly when attempting to engage reverse. This is directly related to the failure of the ATPRVS to provide the necessary feedback to the vehicle's systems. Additionally, drivers may notice that the reverse lights do not illuminate when the vehicle is in reverse gear due to the broken circuit. It's also common for the check engine light to appear on the dashboard, acting as a prompt for the driver that there is an underlying issue that needs attention. Recognizing these symptoms helps technicians correlate the electrical fault with observable driver experiences, enabling a quicker resolution. Understanding how these symptoms directly connect to the error code allows for more effective communication between technicians and vehicle owners. The first step in troubleshooting DTC P1717 involves setting up the vehicle's electrical systems for testing. Begin by turning the ignition switch to the on second position without starting the engine. This powers the vehicle's electronic systems, allowing for proper diagnostic tool operation. Next, shift the gear selector into the reverse position to engage the ATPRVS signal, which will be read through the Honda Diagnostic System, HDS. It's essential to monitor the ATPRVS signal during this step to determine if the circuit is functioning correctly. If the ATPRVS signal is present, it suggests that the issue may potentially be intermittent. If the signal is not present, it may indicate a persistent fault within the system, thus warranting further investigation in the next steps of the troubleshooting. Documentation of these findings is vital for continuous diagnostic tracking. In troubleshooting step 2 for DTC P1717, the technician checks whether the ATPRVS signal is on after shifting into reverse. If the signal is detected as on, it indicates that the system could be experiencing an intermittent failure. Intermittent issues can often be tricky, as they may not present symptoms consistently. Such occurrences suggest that further inspection of the wiring harness and connectors is warranted to catch any irregularities that may not be flagged during this initial test. Conversely, if the ATPRVS signal remains off, it confirms the existence of an issue that merits additional steps for resolution. This distinction is critical for moving forward, as it allows the technician to know whether to continue with deeper diagnostics or to consider system resets or reprogramming of components. Step 3 involves preparing the vehicle for more invasive testing. Begin by turning the ignition switch to lock 0 to ensure safety and to power down the vehicle's systems. Once the ignition is off, the next critical action is to disconnect the transmission range switch connector, providing access to the internal terminals for testing. Attention must be given here, as working with electrical components can pose risks. By disconnecting this component, technicians can proceed to create a jumper wire connection, which will bypass the switch. The jumper wire will connect terminal number 5 from the transmission range switch connector to body ground. This method helps establish if the circuit itself is intact or if the problem lies within the switch. Clear identification of terminal numbers is pivotal for accurate connections and reliable diagnostics. In troubleshooting step 4, the technician connects a jumper wire between the transmission range switch connector terminal number 5 and a solid body ground. This direct connection effectively bypasses the transmission range switch itself, allowing the technician to check if the ATPRVS signal registers as on once the ignition switch is turned to the on second position again. This is a crucial diagnostic step, as it helps determine whether the issue lies within the transmission range switch or elsewhere in the circuit. If the ATPRVS signal turns on in this configuration, it indicates that the transmission range switch is faulty and needs replacement. If the signal remains off, technicians are instructed to move on to further diagnostics of the wiring and connections involved in this circuit, as the problem lies outside of the switch itself. Step 5 commences with the technician ensuring safety by turning the ignition switch back to lock 0, followed by the removal of the jumper wire that was previously connected. At this stage, the focus shifts to the powertrain control module, PCM, a crucial component that manages engine and transmission performance. Disconnecting PCM connector C49P allows access for checking the electrical continuity between the PCM connector terminal C19 and the transmission range switch connector terminal number 5. Establishing proper continuity indicates that there is a good connection between these points. Any breaks or issues in the circuit here would signify a greater electrical fault. It's important for technicians to carry out these checks with precision, as any lapses could lead to misdiagnoses and further complicate repairs. Following successful repairs related to DTC P1717, final verification is essential for ensuring the effectiveness of the work. Technicians should meticulously check all electrical connections, particularly those associated with the transmission range switch and the PCM. This step ensures that no loose or corroded connectors remain that could lead to future issues. If any component was replaced, confirming the correct part installation is critical, as using incorrect components can lead to recurring errors. After verifying connections and replacement parts, the DTC must be cleared from the vehicle system using the HDS, Honda Diagnostic System, to reset the warning lights. This step not only ensures that the vehicle can reliably operate without errors, but also confirms that the system has been restored to its optimal operating condition. Preventive maintenance is essential in averting future occurrences of DTC P1717. Technicians recommend regular electrical system checks to catch possible issues before they escalate. Special attention should be given to inspecting connectors for any signs of corrosion or wear, as this can severely affect the electrical continuity vital for proper component function. Additionally, servicing the wiring harness annually can help identify and mitigate wear and tear early, extending the life of the electrical components. By encouraging regular maintenance, technicians can help vehicle owners avoid the inconvenience of unexpected DTCs and ensure that their Honda Odyssey remains reliable over the long haul. In conclusion, understanding the implications of DTC P1717 is crucial for both technicians and Honda Odyssey owners. This error highlights an electrical issue centered on the transmission range switch and its ATPRVS circuit, which can greatly affect vehicle performance. By following the specified troubleshooting steps, technicians can systematically identify and rectify the problem, ensuring that the vehicle operates safely and correctly. Moreover, implementing preventive maintenance practices not only helps minimize the chances of such issues reoccurring, but also enhances the vehicle's overall longevity and reliability. Continued education on the significance of DTC implications is fundamental for effective maintenance and swift repairs, ultimately leading to enhanced customer satisfaction. Please like and subscribe to the channel. See you next time.